They lied. All of the SAT math gurus have an everything you need to know about Desmos video and promise that these Desmos tricks will improve your score by 100 points overnight, yet it just doesn't work. That makes complete sense though. Tools in the end are just tools and don't work if the user doesn't know how to use it. So today, I'm going to show you all the Desmos patterns I have learned through my hundreds of hours of studying for the SAT. First, we have questions that you can solve by just graphing. This includes two-variable equations, systems, and linear inequalities. With these types of questions, there's literally no thinking involved. You just type the equation into Desmos and find whatever point or area the question is asking you for. Next, we have what I like to call typing practice. This archetype is typically applicable for linear functions and single-variable equations, and all you have to do is type everything you see into Desmos. If it is an equation, you're supposed to use regression, and with functions, usually the answer is just typing out what the question asked into Desmos. Now for data questions, you can solve for these if you have the data using Desmos. How you can do this is just by typing the name of the data type, then parentheses, then just putting all the data inside of the parentheses. I'll put a list of all the commands you need to know for the SAT on screen so you can screenshot it. Finally, we can get on to some of the hardest Desmosable SAT math patterns I've found on the SAT. If you want more like this, check the link on my bio to hack the entire SAT. Well anyways, these three patterns are: one equation, one constraint, an equation is true for all values of x, and use your imagination? Let's go through the first pattern in depth first, and I will explain how you should go about solving these problems. As you can see, here in this problem there is an equation and constraint given. So, what I can do in this case is just type the equation into Desmos using regression, then just use curly braces to set the constraint. If there is more than one equation, you can just use bracket regression instead, and if there are multiple constraints, you can use a comma within the curly braces to separate the variables. The second pattern is even easier to identify and solve. As you can see here, it says that the equation is true for all values of x. In this case, you can just type the problem out using regression formatting, and then on another line do x1 equals negative 100 100 to simulate x equaling all real numbers. This should get you the correct answer. Now the final pattern I'm going to show you is a bit less straightforward than the other ones. These types of questions you typically cannot immediately identify, but after a bit it usually becomes clear. Essentially, it is when you feel like you need more information that you don't have to solve the problem. In this case, you usually need to use formulas you already know to find this additional information. I would memorize formulas such as the axis of symmetry formula, sum of solutions formula, and product of solutions formula just for these types of questions. It is important to note that many hard Desmos questions you will encounter on the SAT will not conform to the rules I've shown you. So, to solve those problems, always remember that Desmos is just about satisfying all conditions given in the problem. If all conditions are satisfied, Desmos will give you the correct answer. Subscribe for more educational SAT content.